C.
The standard deviation is 0.1.
Okay. So is that sigma or is that S?
Sigma.
So it says an unknown population mean and like it's the unknown applies to the standard deviation as well. So that would actually be an S.
Okay.
How about the 50?
The 50 is the sample size.
So which one is it?
Little n.
Yes. This last one here.
5.11. That's the mean.
So X bar or mu.
Mu.
So mu's are for populations.
Oh,
And this
okay.
is a sample. Yeah. So the thing that I think, yeah, I don't know why your instructor's emphasizing this, but these are everything you have right here is for a sample except for the C. But for a population, it would be sigma, it would be big N, and it would be mu. Okay, so remember at the end of yesterday's lesson, we talked this idea about the T going to the Z. So this is one of those problems. Like those formulas that you had been given, they don't work here because this is actually a T confidence interval. Now, maybe you don't know that, maybe you don't care, but like, I think that's what the instructor was referring to. Do you want me to go find that? It was written on the whiteboard, that picture you sent me. Do you want me to go find that to show you, or do you remember what I'm talking about?
I think it'd be more helpful if you could find the picture, please.
Or maybe it was the comment you made. I think you made a comment about the T.
Oh, yeah, I remember that.
That's what this is. I mean, that's what this is, because you're doing a confidence interval and you have to use the formulas that we've been using, the whole, X bar plus or minus Z sigma, or the formulas you've been given, basically. But Z doesn't apply to a T. I'm probably saying too much. We need to go to the calculator and do a confidence interval on this. But it's on a mean. It's on a mean. Okay. So that was the second. Oh man, that was the second stat Z interval. I want to say it was 7. Does that sound right to you?
Let me see.
I'm getting it. I'm getting the calculator out so I can tell you for sure. All right, so calculator on, stat test, not second, stat test. This is wrong. Tests, and then you go over, and this is the Z interval. And you want to choose stats. Okay, so on your screen, you should see a sigma, an X bar, and an N. Do you see that?
Yes.
And so you're going to fill those in. Your sigma is 0.1. Your X bar is 5.11. Your N is 50 and 95 for your C. So go ahead and calculate that. This is the interval that I got. So you can compare to yours, 5.0823, comma 5.1377. Does that match what you have?
Yes.
All right. So now when you go to the answers that are given, this is so good. This is so modern. I mean, you've taken some standardized tests. Like, this is the modern way to do it. Colors, shapes. Which one matches up to this? It's
The
okay.
blue one.
Yeah, it's okay to exclude, say, oh, it's not that one, it's not that one.
Okay.
So like I don't want to say much more on this whole like TZ thing because you will see it, but um you're supposed to use the it's this you only have two confidence intervals. You have the ones for means and the one for proportions.
Mhm.
So don't overthink it, I guess is what I'm trying to say here.
Okay.
All right. Did you already try some of these? Because I don't see number 2.
I did not. I already did number 2.
Okay. All right, here we go for number 3. If I can find it. Here we go. All right, this is number 3. It says, suppose you were to change the confidence level from 90 to 95% using the same sample. How would the confidence interval change? That's asking about the width. The width and the margin of error are basically the same in terms of like how they're affected. Do you remember from yesterday, as the confidence goes up, do you remember what happens to the width?
As the confidence goes up, does the width also go up?
Yes. So I probably asked you stuff like this before, but how are you going to remember that? Like, how will you know this information tomorrow before the test so that you're not at all, it's not unclear at all?
I'm not really sure.
Okay. Okay. Yeah, I wish I had a good way to do it. Yeah, maybe like they call it a brain dump. You just go to the top of your test. That's the first thing you write
Mhm.
down. C up, W up, C down, W down. And then the other one was N up, W down, N down, W up. Somehow doing that. Okay, but in terms of answering the question here correctly, we want the one that says that it gets wider. So which of these say that it gets wider?
The yellow circle.
Yes. So these confidence intervals, they either get wider or narrower. So it's never shifting. There are ways to shift it, but I don't think that that's what your instructor is trying to emphasize here. So, all right. I don't know which question this is. I'll just let me snip this one in. It's like giving you some feedback already. Here we go. It says if a confidence interval is 3.21 plus or minus 1.96 times 0.09, what is the point estimate? The point estimate always refers back to the number in front of the plus or minus. So the point estimate is either the X bar if you're doing it for a mean, or it's the P hat if you're doing it for a proportion.
Okay.
And so in terms of the answer, we care about getting this right. It's the number that's in front of the plus or minus, which is this one right here.
Okay.
This is just a straight definition. There's not much more to say on that. Here's another one that does not have, I don't know which number it is. So let me just grab it before we go to 5. Maybe these are 4, 2 and 4. Okay, if the confidence interval is 3.4 comma 10.2, what is the margin of error? So I always like to just draw this left bound, right bound. This is really the upper limit, and this is the lower limit. And then you want to find the midpoint, the average of the two. So you can add it up, divide by 2. Will you tell me the midpoint between these?
So you add them together and then divide by 2.
Yeah, you're just finding the average.
Mm. 6.8.
Okay, so that's the place right in the middle. So in terms of like what's going on here, the width of the confidence interval is the entire length of this. Okay, so to find the width, you take 10.2 and subtract 3.4.
Okay.
Which I think is also 6.8, which maybe is why this was chosen. The margin of error is half the width. So the margin of error is half the width. So the width is the full length. The margin of error is half of that. So half of 6.8 is 3.4.
Okay.
So I'm gonna give you one like this to try, because I think this one had some deceptive numbers in there. But in terms of your answer here, it's just asking for the margin of error. It is the 3.4. Okay, so let me give you another problem here to try with different numbers in it. All right, so let's say this time it's let's not make this overly complicated. Let's go 16.5 and 20.5. So I recommend drawing it, but that's up to you. And then figuring out the width, how wide it is, and then cutting that in half.
Okay. So the width is 18.5 and the margin of error is 9.25.
The 18.5 is the midpoint. It's right in the middle. The width is the length here. The width is the right minus the left.
Oh, okay.
So that's the 20.5 minus the 16.5.
And then half of that is the margin of error, so
Yes.
2.
So notice it 18.5 plus 2 gets you to 20.5.
Mhm.
And then 18.5 minus 2 gets you to the 16.5.
Okay. Oh,
Yes.
okay.
So let's try another one here. This is all good stuff that you're getting. Let me just give you another one. Okay, now, I'm not saying you'll get this, but you could get negative numbers. You could get -9 to -3. Depending on what you're doing, this is totally reasonable. Your widths, just like your lengths, they're always positive. Your margin of error will be positive. So give this a try, see what you come up with.
The width is 6 and the margin of error is 3.
That's right. That's perfect. You got it. Okay, so we can move on to some other questions now. Let's see if there's any other ones here. Nope, these are all sort of more, these are all a little different. Okay. Here we go. All right. I'm gonna again kind of say, like, with these longer ones, it's probably good to go to the last sentence first. Just figure out like what they're asking you to do. That way
Okay.
you know what you're looking for. It says find a 99% confidence interval for the mean monthly rent. So it's on the mean, which is good. Really good. Okay, you want to rent an unfurnished one-bedroom apartment in Boston next year. The mean monthly rent for a simple random sample of 32 apartments advertised in the local newspaper is $1,400 with a standard deviation of 220. Find a 99% confidence interval for the mean. So I again want you to tell me what each of these numbers are with respect to the letter, whether it's a sample or a population.
It's a sample.
Yes, they're all samples. So give me the correct letters here.
Let's see. Okay. C is 99.
Okay.
The standard deviation is 220.
Okay, so that's little s.
Yes. Um, let's see. 32 is little n. And then 1400. Is 1400 the mean?
It is. So we've got to be more careful though. I'm trying to be careful here. I want to make sure that these are the right symbols to write.
Yeah.
because this is also the mean,
Mhm.
but it's the population mean.
Yes.
Okay, so the instructor is looking for this. Okay. All right, so since it's a population mean confidence interval, you're going to use the same one we started out with, the stat tests z interval.
Okay.
Okay, so again, go ahead and calculate that and let me know what you come up with.
I got 1,299.8 to 1,500.2.
Good. So which of these will it be?
Um,
Looks like your instructor has a mistake on his.
I guess the closest one is the red.
Yeah, this isn't very good. Let me do something real quick to make sure that he didn't accidentally use a t distribution. Let's just check this one. All right, so same thing here. It's 99%, right? Yep. Domain, why doesn't it like that? Stat. All right. X bar. Oh, I didn't give it the standard deviation 220. That's why I didn't like it. So this is probably the correct answer. I'm sorry to create some confusion. If you
Mhm.
use a t distribution, this is the correct answer. I don't know what to tell you though, because you made a comment like those wouldn't be on there.
Uh-huh.
So let's just move on and hope that that doesn't happen. Or you could ask him. You could just say, "Hey, I was working on number 5, and I noticed that if I used a t distribution," and he'll know what that means. I mean, I got this answer, and when I used the z, I kind of got the red, but not quite right. I don't know. You have time before class to do you have any moments before class or earlier in the day to go ask?
I probably could. I'm
Okay.
kind of confused why it's a different answer.
The main difference between the two confidence intervals is the whether you use a ZC or a TC value. And this
Mhm.
TC value changes based on the sample size, based on N. And I don't know if you want more information than that, but basically it's two different numbers. That's why you get two different windows.
Okay.
We should move on. We should just keep going through these. I mean, chances are you would write out your answer and it's not multiple choice and you'll be okay.
Okay.
All right. Again, probably good to go to the last sentence here. Calculate a 90% confidence interval for the average cooking time of a 10-pound turkey. So we got a bunch of numbers here: 19, 2.9, 0.24, and 19 again. That's probably the same value, but we want to know what each of those symbols are.
Okay.
So go ahead and read it over, see what you come up with, and
19 is little n.
Good.
2.9 hours is x bar.
Good. Good.
0.24 is little s.
Good.
And 90% is c.
Good. Okay, so do a Z interval and see what you come up with. I'm doing the same. And hopefully we get really consistent results here.
I got 2.8094 to 2.9906.
Yeah, so when the answer, I think you already answered this one, but the answer is 2.8 to 3. You got it.
Okay.
Oh, do you have the ability to check number 5, the one we just did, to see which one is right? Or is this graded, or is this like it'd be okay if you?
It's not graded, but I have the answers if you'd like me to double check.
Well, I'm really curious because this one probably is the right answer. Because it's really bothersome. I mean, I don't want you to go in there without any doubts. It's up to you. I mean, I'd like to hear that it's red. The answer is the red one, because then everything I said can be disregarded.
Okay. I'll look right now.
If it's not quick, I mean, we can if it's not that easy, we can just move on to this new question.
Oh, the answer to number 5, that one is I think it's the circle between
Yeah. Okay.
1293.
Okay. Because that impacts this one here. That really, this one. So there's this idea that use the T distribution, especially when there's small samples.
Yeah.
Okay. So in terms of the calculation, this is very, very straightforward. We're going to go right to the calculator. I'm going to share that screen. We're going to put this data in L1. Have you been doing that at all in class?
No.
Really? Oh no.
Yeah.
Okay. Well, how would you calculate the mean and standard deviation of this? All right, well, let me just show you. I mean, that's really what should happen here. So if you're seeing my screen, you're seeing the calculator. The calculator will do this for us. Okay. So I'm going to go to stat edit. I'm sorry, stat edit, and then hit enter. Stat edit right there, number 1. So I'm going to put these data points in for L1. So 10, 6, 8, 7, 6, 5, 7, 8. Okay. So if you're following along, and then I always quit out just to make sure that don't do anything weird inside the list. So now you can go stat calc 1 variable stats. And by default, yours is going to give you options, but by default, I think you got to give it list 1. You just want to, yours probably already says that, and you'll have a paste option. But you should see something like this when you're all done.
How did you get to that page again?
So it's under stat edit is how you edit the list. That was the first thing. Okay. And then stat calc under the calc menu, 1 var stats, 1 variable stats. Enter. And then yours probably has like a few options, but you're just going to use list 1 for it.
Okay.
And I'd like you, if you've entered the data, I'd like to hopefully confirm that you got the same X bar value.
Yes.
Okay.
Yes.
So that's what you need. You need X bar 7.125. And then this is where it gets dicey because I don't know if this is a T distribution or not. I'm so sorry. I mean, this isn't complicated. It's just I don't know where you're at in the course. I don't know what is going on with why it was, but that makes it harder for me to help you. So let's just use the sigma value. 1.45. Okay. So I've written those down. Now you go back to your stat tests Z interval. Okay. And then just to keep it simple, you want to enter that information. So your sigma was 1.45. Your X bar was 7.125. Your N was 8. And your confidence level this time is 95. So 0.95 like that. And then you'll calculate. And issue here is you get the lower bound, but not the upper. And that's because this is really a T distribution. Sorry, let me go just check T interval with the data. Let's just do it with the data. 0.95, calculate. Yeah, so this is bad. I mean, this is really, you're supposed to use a T interval on this problem. So I'm not sure what to suggest. So I guess I would say go talk to your teacher and say, I noticed that on 7 and 5, the answer was used a T interval. And see if it's like, oh, don't worry about that. That won't happen, or.
Okay.
That's my best recommendation. Let's go to number 10. 10 is very clear how to do, so there won't be any issues with this one or the next two, but. All right, in a simple random sample of 250 high school students, it was found that 85% of them later graduated. Find the 98% confidence interval for the true proportion of all high school students who graduate. Same thing as the previous problem here. We need to know, your instructor may want to know what each of those values represent.
Okay.
So take a look, let me know.
Oh, can you flip your screen, please?
Oh, I'm sorry. Boy, I haven't done that in a while. I did it tonight. Yes, sorry. I Jeez. All right, sorry about that. I read the problem, I circled the numbers. Go ahead and take a look and see what each of these are, what they represent.
C is 0.98.
Good,
Little n is 250.
okay.
And then is it X bar for 0.85?
It's p hat, it's the proportion,
Okay.
because it
Okay.
even says here proportion.
Yeah.
That's the differentiation in the language is a proportion.
Okay.
All right, so this one you're going to go to your calculator, but if you recall, you got to make sure that because your calculator requires x is n times p hat. You've got to check if 250 times 0.85 is a whole number first.
Okay.
So you're going to grab your calculator, multiply, and hope that it is. It is not.
Yeah, it's not.
So this is where you have to use the formula by hand. So the formula is p hat plus or minus zc square root p hat 1 minus p hat over n. So you have p hat and you
Mhm.
have n. You don't have the zc.
Mhm.
So remember from last night, you have to do something to find the zc. Do you remember that, where that is?
It's the inv norm, right?
Yeah, under second distribution, I believe.
Okay.
Now for that one, that was kind of that off to the side. Your mu is 0, your sigma is 1, always for that.
And then your area is that 0.98?
Yes, yes.
Okay. Negative 2.32.
That doesn't seem right. Let me just check. It should be like 2.33. Sorry, let me I didn't have that one up. Yeah, so it should be something different. Are you using the center?
Yes.
Okay, 0.98, 0 and 1.
Yes.
It should be minus 2.33.
I got negative 2.326.
Yeah. Yes. Okay, maybe I misheard. I'm sorry. Yes, that's fine. That's close enough.
Okay. Okay.
So that's your ZC. So it's the 0.85 plus or minus. You can use the positive or the negative, doesn't matter. And then 0.85, 1 minus 0.85, and then your n is 250.
Okay.
So give that a try. You have to do it for both the positive and the negative.
Okay.
Let me know what you come up with.
.90.
Okay, so that's the upper. Now we just need the lower. So the only thing you're going to change is the plus to the minus.
Okay. The other one is 0.97.
Do you mean 797?
Yes, 797.
Yeah, so about 0.80. Now, real quick here, what is the width of this interval?
The width. So that is when that's when you subtract 0.9 from 0.8, right?
Yes,
Okay, so the width is 0.1.
good. What's the margin of error?
Okay. Margin of error is half of the width, so 0.05.
Good. Okay, now if n increases in this problem, what happens to the width?
If n increases, the width decreases.
Yes, good. Okay, and so the answer to this one, it's the blue, if you need to check that. All right, so let's go to the last two real quick. These are the sample size needed.
Okay.
Actually, let's not do that one first. Sorry, let's do the other one first. Sorry, we'll do the other one first. So again, you need the formula for this. So just because we are getting low on time here, let me help out here. So the margin of error is 1.5, the C is 0.95, and sigma is 7. Okay. So
Okay.
from the other day, the formula is N is ZC times sigma divided by the margin of error squared. You are lacking the ZC value. So you got to get the ZC from the C,
Okay.
just like you did. So could you calculate that for us real quick, please?
Negative 1.96.
Good. Okay, so you go to your formula here, 1.96 times your sigma is 7. Your margin of error is 1.5. And do you remember what the last thing you do once you calculate this value is? Just one little extra thing that has to be done.
I don't remember.
You have to round up.
Oh, okay, to the nearest whole number.
Yes.
Okay.
So you're welcome to calculate that. It's the orange one. I guess that's orange. I don't know.
Okay.
It's debatable. Maybe it's, okay. So the other one here is proportions. This one's not as easy. It's a harder formula, I guess, to remember. You said you'd probably get those. So the margin of error this time is 0.03. The C is 0.95. So just like last time, the ZC is 1.96. And so the formula for N this time is the ZC over the margin of error squared. But then there's like this little additional thing that it doesn't really talk about here. So it's P hat times 1 minus P hat. And notice they don't give you that value. So,
Mhm.
if you don't know p hat, you use 0.5.
Okay.
And that's just a standard thing here. ZC is 1.96, margin of error is 0.03, squared p hat is 0.5, 1 minus 0.5. Go ahead and calculate that. And again, you do want to round up here when you're doing this calculation.
Okay.
Excuse me.
I got 1067.1.
Okay, so what would you write as your final answer?
1067.
You have to round up.
1068.
Yes. Like even if it looks like it rounds down, you round up. So on a standardized test, like you see these in colleges, they'll give you both answers. I don't think your instructor will, because that's pretty tough, but it's a big deal.
Okay.
I don't want to say why, but they really emphasize that. So
Okay.
all right. Well, that'll do it for tonight. How are you feeling going into the exam?